I think it's about time to start. We're a little late, but well, that happens sometimes when you try to step out of your comfort zone and try to do something in a different stack than you're used to. That's also part of why I'm giving this talk today. So today we are going to talk about a bit of full stack engineering, and we're going to use Kotlin multi-platform for that. Just wondering who of you has experience with Kotlin. Let's start with Kotlin. I have a lot of experience with Kotlin. I think see some hands here. I'm not really able to see you guys online if you have experience, but I'll assume you have at least some, seeing that you joined this one. Who of you knows about Kotlin multi-platform or maybe multi-platform mobile? I see 2 hands, 3 hands, and a bit. All right, so we've got some experience, we've got some less experience. Are you guys generally full stack or like single stack? Who's full stack? Who does both native, front end, back end, at least more than one, let's say. Okay, still seeing some hands, but mostly not really. All right, that's good to know. So let's dive into it for today. And I think in half an hour, maybe 40 minutes, you all know how to actually start programming in Kotlin multi-platform. So a little bit about me. I'm an engineer at Flock Community, which is a community of software engineers who are trying to build a better world by trying to make better software each and every day. And I do that for several clients, some of which are very happy to start using Kotlin, some of which aren't so happy about using Kotlin yet. But of course, our goal is to make everybody use Kotlin, not only for backend development, not only for Android, but actually for everything, because I believe that Kotlin multi-platform is a nice stepping stone to do that. So that is also what we're going to talk about today. We're going to talk about Kotlin multi-platform. It's basically a tool for you that gives you the ability to stop writing code multiple times if you need to an implementation in different platforms. So you have an iOS app and an Android app, and they need to do sort of the same thing. Like you have a web shop and you want to have a good experience, you're probably ending up with 2 code bases that looks sort of similar. What if you could only have a single code base that sort of holds all that common logic and all that stuff, and then actually expose that and start using that as a starting point for your mobile application, making your mobile application way leaner and way smaller in terms of the actual lines of code that you need to implement on that part. Well, let's look at what's available. There are several platforms actually available for which you can start using Kotlin multi-platform. And I guess we're going to touch on some of those, but the most important ones are iOS. And actually not only iOS, but everything that's related to OS X. So there's also watchOS, tvOS, that whole chain basically. And it's actually enabled also for the new M1 and M2 chips. Then of course we've got JVM, sort of the thing that Kotlin started with. We've got JS main, so yes, you can actually start exposing stuff to JavaScript and stuff, or actually start using Kotlin JS, which is sort of like a JavaScript type flavor, but then Kotlinified. So you basically get a DSL to start writing your HTML declarative. And then of course we've got the more desktop stuff, which means you can build your native applications. But we'll get to that during this meetup. Of course, if you have questions during the meetup, just raise your hand. I'll try to look behind me so I can see you guys online on the screen. And over here, I have a pretty good view of you. So when should you start using Kotlin multi-platform, or when shouldn't you? Well, you could see as a rule of thumb, you could say if there's client-side logic, which you cannot do on the server, but you need to do on multiple different clients on multiple different platforms, say an Android app or an iOS app or a web and maybe a native app or something like that, then it might be a good idea to start using just a single code base for the common code and only do the platform specific stuff on that platform. So it could be a case that you don't have internet, so you can't actually access a server somewhere. Well, then it makes sense, of course, to maybe start using KMP. Maybe if there needs to be something with security stuff related, which you can't really do from a common perspective, but is really platform bound, then of course those are essentially your platform specific controls. So how do you interact with the file system and stuff? That's of course very specific for the platform. And the reuse part is of course an interesting one. even if you don't need like the specifics like internet or secure API, but you do need to share a lot of logic still, it might be beneficial to start looking into Kotlin multi-platform. So how do you actually start with a project if you want to do multi-platform? Well, it's Kotlin and Gradle are sort of good friends, and you basically have a plugin that you need to add to your build at Gradle, which says I want to use Kotlin multi-platform with a certain version. I'm a little bit behind. And that's basically it. That's somewhere you get a property available, which is called Kotlin. And in there, you start defining the platforms for which you want to start coding. But it's in essence, it's nothing more than this. This basically gives you access to all those different platforms that we just saw. Of course, I want to make it a little more appealing to you. So the question is, what is it that we're actually going to implement now? And funny thing is, I actually found a small company called Garble, which has some problems, and they want to have a solution which could potentially be multi-platform. Yes, this is fictional. So it's Garble. This is their head office. It's a company that does things, and it's led by a guy named Jack. This is Jack. Say hi to Jack. So Jack has a use case for me and says, hey, Julius, I need to generate passwords every now and then for company accounts or maybe apps we actually generate with our company in there and all these different platforms, right? We've got Ivy that's coming up with her iPhone. We've got Peter that's coming by saying, hi, I still work on a DOS machine. Can we do something for that? We've got some Linux geeks over here. So how can we do something that, you know, once and for all, we get a password generator that works for everybody? Can you do that? Well, I'm not sure if I can do that, but at least I can try, right? So let's start with defining a function, because what we want to do is we want to generate a password. So that's going to be our use case, how to generate a password. And well, that question is the same for all platforms. Give me a password. But of course, we could just start with a very naive implementation, saying, give me a password, I give you a length. I say there are a couple of characters you can use, so everything from A to Z in capital, everything from A to Z in lowercase. And then we just repeat that we say from the random class from Kotlin, get the next integer given the size of my character pool, essentially, and keep adding that to my password. And then you return that, and then there's an example on the bottom. If you call it, give me a password with argument 10, then it returns just some random string. A pass garble, you might call it. Of course, the question now arises, what is actually wrong with this? And the most important one is typically you shouldn't be doing your own cryptography. There are guys that have studied years and years for this, and typically you should piggyback on what others have thought is a good idea to do cryptography. Second of all, please don't do your own cryptography. So if you really want to do it, keep paying attention, but this might not be the best example you want to try in real world, or you should not be using it for very serious applications. So if you think you're gonna go into crypto and you're gonna use this, don't even think about it. But if it's like, I don't know, you wanna make sure your printer is safe or something, this should still be usable. The problem with this particular thing, if we're gonna dive into it, is that the random class in Kotlin is not really that secure. It only has a variation of, I think, 32 bits, which in cryptography world is not that much and actually get you into trouble. So the variation that you actually can get in terms of different passwords isn't that big. And of course, more from a user perspective, it's rather limited in terms of how you can use this, right? You can only use uppercase and lowercase. You can't even decide which ones to use. How about those numbers or special characters, all those kind of things? Okay, sure. Knowing that, we're going to rework the function a little bit, and then actually we're going to see where we need to find a hook to the platforms, because of course we need to do some platform-specific work here as well. So we're going to focus on getting a random character from that character pool. So we have a character pool with essentially a list of characters, and we basically say from that character pool, get a character at a certain index, and that index is determined by actually getting a random int based on the carpool, or actually the size of the character pool. Then we already start to get into a little more complicated stuff. I'm not going to go into detail, but essentially what this is doing, it's saying I want to get a secure random byte from somewhere, and I want to do that until I make sure that the byte that I get back is sort of nicely distributed over the range that I'm requesting it for. We could go into detail about this, but that's not the point I'm trying to make during this presentation. We can come back to this in the questionnaire at the end. So the focus that I want to put on here is the get secure random bytes, because that is where we can benefit from the platforms that we're going to implement this on. And when I say benefit from the thing that we're going to go to platforms, is where we're going to use an expect keyword. So I've created a function, that function called get secure random bytes, and I put a little keyword in front of it called expect. And actually what that expect thing does, it is provide a hook to platform-specific functionality. So there's actually not an implementation of this one, because it's an expect function, but Kotlin expects me to provide an actual function. So actually they come in pairs. Well, not necessarily pairs, they come in they're sort of bound together. So if you have an expect one for every platform that you're going to implement, you also need an actual function. So basically an implementation to your interface, you could say. But it expects that one, and that way you can actually benefit from the functionality of the platform. Let's take a very simple example. Here's an overview of how this should work. So in the common source set, and we're going to see that in a bit, the common source set, I expect a certain function or expect a certain class to be present, but I can define its interface. And then in the implementation, in this case, an iOS or an Android, I actually define what that function is, or I give the actual implementation of that function, both for Android and iOS. And of course, the benefit is in iOS, I can use the native libraries that are supported by iOS, and in Android, I can use the native, or not native, I can use the JVM libraries, because Android is JVM based. A very maybe trivial example is a logger. Maybe you want to provide logging functionality to each and every one of your platforms for the common stuff that they're doing with you. So I expect a log message function to be implemented, and then I have the ability within the common platform myself, or the common part myself, to actually write those log messages using the write log message function that will be implemented by the different platforms. And here are two examples. So for JVM, for example, we just used the simple print line function from Kotlin, but it's actually bound to a JVM thing. And maybe for JS, we say we want to use the console logger from either the browser or the Node V8 engine. That makes sense? All right, see some nodding. All right, so we actually got our first customer. His name is Jonathan Van Moor. Maybe you recognize him from Garble somewhere if you've been around, maybe not. And he's asking me, can you give me a library to actually generate passwords? Because I need it for this Garble app that I'm working on to generate passwords for whenever a new user is actually creating an account. And I want to give them like a secure password when they start, blah, 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 that whole thing. Well, funnily, I know that Jonathan Van Moor has the initials JVM, and so I can assume that he's actually doing something with either Android or Java or whatever. So we're gonna go on that assumption and say, okay, let's start implementing a JVM library. So now we're going back to our build Gradle file, and what we're gonna do is we're gonna say in the Kotlin thingy, hey, we want to do something with JVM. Okay, sure, we're going to do something with JVM. We're going to say that we need to target